everybody. Good afternoon to those in Europe. I'm Bruno from FMECA Technologies Automation Studio. I'm accompanied by my colleague Denis Lenub, who's our product manager on Automation Studio. And today you've joined us for the webinar on Analyze Failure Modes, their effects, and their criticality. This is a new module coming in the 7.0 version. Right now you're at the third of our 6 webinars. So we've already released the first 2 webinars. We've done these on January 2nd. Well, sorry, I should probably fix the date there. It's not January 2nd that we did. I apologize for that there. We did one 2 weeks ago. We did one also 1 week ago. We had sent out all the videos to everybody that had registered. If anybody is requiring any videos, it's no problem at all. You can write us in the chat. In any case, after this meeting, you'll get a link to this webinar, and also you'll get the information on an FTP link to be able to connect to this video, and also all the previous videos and all the future videos we'll be posting at that location as well. At any time during the presentation, if you have any questions at all, feel free to write them directly in the chat. This is the best way for us to be able to manage your questions. We have a lot of people in the meeting that will be able to answer some of those questions, and we'll use some of them also in the Q&A at the last 30 minutes. So first hour will be for the presentation, and the last 30 minutes specifically for questions and answers. Regarding the agenda that we have today, the first part will be looking a little bit at some of the features overview of Automation Studio in order to be able to set up what would be required to perform an FMECA analysis. So we'll be going through those features, how you can set up your schematic in order to be able to get to the point where you can perform an FMECA. And this information, it's reusable between departments in order to be able, at the end of the day, to share information, critical information on possible failure modes of your system to be able to more support the technicians. That about sums it up. Denis, I'll let you maybe take the lead on the, on the next sections.
Thank you, Bruno. Hi, everybody. So prior jumping into the demonstration, I would like to recap a little bit about the failure mode effect and criticality analysis. So the FMECA has been developed and used in the 60s, first in aeronautics and nuclear weapons domain. And later, it has been formalized in a systematic process described in the 3 standards here, so IEC, MEL, and NF. We follow by default in Automation Studio the IEC 6812, but the difference between those standards, it's only regarding the information, the type of information, and the grading of evaluating severity, criticality of failure modes. But the concept for all those 3 standards are the same. And the concept of the FMECA is finally to identify all the system failure modes that are caused by components failure modes. So we talk about components that participate to the architecture of this of the system. At the end of the analysis, we get a system information report with qualitative and quantitative information that will be useful first for the design department in order to improve reliability of the system, and after sales support to make the support efficient when troubleshooting occurs on the field. The scope of the analysis finally is that the FMECA is applicable on both stationary and mobile systems. It can be applied on the entire system, but part of the system. You can apply this only on a specific technology. Let's talk about hydraulic or electrical technologies or pneumatic, but you can apply on all. And as well as you can select all the operational mode of all the functions, but you can also apply FMECA only on new function or new options that are developed on an existing product. So it is really open. You can apply FMECA on a new project, but also on an existing project. To conduct the presentation, so I will just get back here. I will use a numerical digital model of a rocker for trucks. So this example is a multi-technology system. We have hydraulic system, hydraulic control of this rocker, and we have the electrical control here on the right side, and the power electrical that drive the motor here. We have also a control panel. So I just want to hide a little bit an image. We have a control panel to illustrate that we can deal with automated system as well as manual system. So let's start the presentation of the model. So for the moment, I will control my system manually. So as you can see, the presentation of the model, it has been drawn by using generic components, but it could have been done with a manufactured product, for which we have presentation on our first webinar. And here, so the simulation, as you can see, the motor has been controlled, and I can control dynamically my system. So the objective is to empty a container for trucks who do not have lifting functions, of course. The productivity of such a system, from my research, the example I have taken from the website here, I have this website. This is a picture coming from here. The production has been described as 15 truck per minute. No, for 15 trucks per hour, sorry. And of course, for the presentation of the system, for the webinar, I have downsized the actuation. I have downsized the pump in order to have roughly a 35-second sequence. So you can see here also, so hydraulic, electrical, control panel. We'll just stop my simulation. And we have also the mechanical link that are done between the cylinder and finally the rocker itself. Just to analyze a little bit the system, so it is a very simplified system in order to go through many functions of this module. I would like just to comment a little bit the behavior of this system. So we have finally, if we want to resume, we have one function. This is a rocker. So we have one function, and we illustrate here different operational mode of this function. So we have the lifting. This curve represents the stroke of the cylinder, so the inclination of the rocker. And we have first operational mode is the lifting of the truck. Second operational mode, if you remember, I just want, maybe I can restart the simulation a little bit. I will automate with a sequence diagram my system. And just to comment, we have, so the lifting, after the material start to be empty from the container, we will have a delay of standby position, which is a delicate operational mode. And after 8 seconds, I have selected 8 seconds to wait, we have finally the truck return in the down position to be able to exit, and so on. So just for to define the first objective, starting with this model, I have to finalize an explanation. All this model, I will hide all the window I don't need. So in this model, so there is hydraulic component. If I have a look, it is important, if you remember the concept we have described in the introduction here, we have to identify the system failure mode caused by component failure mode. So in Automation Studio, maybe you know, I guess you know, I mean, it exists for a long time. We are able to declare component failure mode in many components. So here I launch a diagnostics that will show where are declared component failures. So in my example here, I have declared few failure modes in those components. We have done this in the electrical, but in the hydraulical workshop, but of course in the electrical. So here I'm using, this is a drawing, this is an embedded view, so I will reach my electrical circuit by following this link. So finally, I am jumped into this electrical drawing I show on the Project Explorer on the right side. And here, We have the same diagnostic, of course, that can be launched on the electrical side, could be done in pneumatic side also. And here I have declared less failure. It is just to illustrate the fact. So here, for example, I have my engine in my troubleshooting branch. Sorry, I have declared this failure. I haven't declared the gem motor, the gem rotor. And the important thing it is just a recap. It is not an explanation of how to use this module. But I have declared the failure, but it is not activated. So it means that in the simulator, this failure exists, but is not activated. And we will see that the module of FMECA will be able to activate automatically each failure one by one in order to see the consequence during the duty cycle of the system. So let's return into the main circuit, and we're gonna define the first objective will be to identify first prior measuring, using features in the design process. We have to define some characteristic of the system. The first one will be the function, and we will specify operational mode. So we will go to analyze. We will do it with the entire system. So as I mentioned in my plotter, I have one function but 3 operational modes. So first step is to grab the performance, the economic performance of my complete system. I will do the following steps. First, I have to declare a function, the function of my system. To do this, I have to go into this tab. This is the tab that is added when you have this module in your license, and it deals with failure analysis. So we have the function dialog creation. It is a very simplified dialog. You just have to add your function. My function, as I mentioned, is only one function. So we call it rocker. And to define a function, we have to declare for this function which components participate to this function. So for the moment, I will simplify this, so we can select component from fluid system, from electrical system. So just to speed up the process, I will select all my functional group that handle the component of the system. So I have no time this morning to recap how you work with a functional group, but it could be done later if we have time. I mean, at the end of the main presentation. The same, we're gonna select all the electrical component and fluid component. So what you have to remind here, when I create a function, I name it, and I select all the functional group components that participate to it. So it is easy here, I select everything, okay? As soon as we have done this function, we have created the function, we have to declare what operational mode I want to analyze. So what I'm gonna do, I'm gonna open, the second step is to open the operational mode dialog. You can see that when I open this dialog, by default, I have the function that has been created into the system that are displayed directly here. And now to declare an operational mode, to declare an operational mode, I have to add it. And as soon as I had the operational mode, you can see 4 tabs that are added automatically when I select my operational mode. So the first tab is the details. This is where we're gonna name the operational mode. So my first objective, as I mentioned, this is the duty cycle of the system here, lifting, standby, lowering. So I want to, I will call it duty cycle, if you don't mind. I hope the word is adapted. And I have to now assign this operational mode to the function, one of the function of the system. Of course, you see I have only the rocker function, so I will select the rocker. You can put some description. What is important, I remind you, my objective, first objective is to measure the performance, the global performance. So I'm talking about the timing of the duty cycle, the energy consumption of the duty cycle. So in order to measure this, I have here a checkbox that will, if you see the green button here, when I uncheck this, it is not considered. If I check this, it means if I pop up this button, you see that the operational mode will be taken into consideration when you measure performance automatically, which will be done with this button, and it will be used also during the analyze. So I will get back as soon as we will use it. So the duty cycle, like any operational mode, there is a beginning and the end of the operational mode. For example, the duty cycle will start here. So let me just add a little vertical viewer here. So we have the beginning and we have the end of my duty cycle here. Sorry, an autosave in progress. So the end is at the end when the stroke of the cylinder finally is 0. So let me just zoom. So I have to, this is the beginning, in order to trigger the automatic measurement, we have to specify the activation condition of the operational mode, as well as the termination condition of this operational mode. So here, to define the activation condition, we have to go in the second tab. So let me just close this window. And what is the activation condition? So there is many ways to create an activation condition. It depends on how you want to control your system and how it is designed. For example, here, if I start my simulation, I have put here a proximity sensor, okay, that trigger finally a variable, A0, and we can see obviously that it is open. So it is the A0 on the edition mode, we see it is open, so it's false. When I start my first step of simulation, I will see that E0, the contact, will close. So it means when I start finally the simulation and the system, A0 is true. So we can think to just use A0 to declare that if A0 is false, it means my cylinder start to extend. So it means I will have trigger somewhere my start button here, or this one, or this one. So to create an activation condition, I will use A0. So prior editing this condition, I just want to recap here the interface for people who are very who use some, for example, controllers. You can recognize something that is really close to this interface, the list of variables in the system, and some syntax and operator that can be helpful to create a function, a condition. So I will use some, so I will double click on A0. So here you see I have a syntax that is added automatically. H5-1, it is just the internal ID of this component. .A0, it is the name of the variable of the contact. So of course, if I put this condition activation, sorry, it won't be the activation condition, because it will explain that we are in the initial position. So to be sure that the cylinder extends, we must add the note A1. So I don't want to, it's not a course on the logic, but I think it is relatively obvious to say that if we don't have A0, it means the cylinder has started the extension. Now, for the termination condition, we have seen that the cylinder extend, standby, retract. So the retraction, if we say normally after the end of the cycle, A0 will be true. So we can use once again the A0. So we double click A0, but the problem is A0 is true at the beginning. So we have to add another condition. And just information, the simulator, when it starts to measure the performance because an activation condition has started, you need to know that for each failure operational mode, a timer, local timer, will be started for each operational mode. And this timer is represented by this operator here. So if I use this operator, I just have to say that the termination condition will be true if A0 is true and the local time of the duty cycle operational mode is bigger than a certain value. So we know the sequence is roughly 35 seconds, so I will just say 10 seconds, just to be sure I am not in the sorry. Just to be sure that I am not at the beginning of the initial position. I mean, here you see I have written this. It's a syntax error. We have to follow the syntax by using those operators. So as soon as you will use it 1 or 2 times, you will see that to give the value of the time, you have to use this syntax operator, and here you have to add the value and the unit. The unit can be in second, in millisecond. You can look for, there is an automatic recognition about the unit. So of course I don't want to have this, I will keep second. Second remark, you will see the syntax, we follow the color syntax for this expression. It is true for activation condition, termination condition, and performance. Black is for the variable. The blue is for the operator and feature and functions, and green generally is for, not generally, all the time, is for the numerical value. As soon as I have done this, I will I will save my data, and now I have to finalize what performance, how I measure the performance. To measure the performance, and this is shown in this tooltip, in order to measure the performance, you need to insert dynamic measuring instrument into your system. So the third and last step prior measuring the performance is to insert dynamic measuring instrument. So my dynamic measuring instrument are here. They are on a layer. So I have to just display my layer manager. It is on the left screen, sorry. So I just want to here, okay, and I just want to avoid this to occur. So I have displayed my dynamic measuring instrument. So let me grab some. We have 4 types of dynamic measuring instrument. On the electrical side, of course, we have the same. So let's grab for example, the output flow of the pump. Let's use the pressure, the 1 node dynamic measuring instrument onto this piston side pressure port. Let's take, okay, the energy measurement. So I put many dynamic measuring instruments because I want to show you some restriction, and this is for the first version, but you will see already we have many things to do with the first release of this module. I have also inserted, I have used from the library this object that finally will measure the time of the duty cycle as soon as this motor will run. So it is a condition. I don't want to go into details, but it can be shown in other presentation if need be. So this is an output signal unitless because it is a component that does not use unit, but of course I have made a scale to have the value in seconds. So I just want to use this. And here I have created with controllers energy component, component that measure energy in different units. It is helpful because you will see for the first release, this component that measure energy won't be able to be used. So in order to do this, I have to, and this is components. So I am able to add this here. So I'm talking in horsepower, and now I am ready to start my, not my simulation, the measurement of my performance for the duty cycle. So to do this, I have to reopen this dialog here. I think I am ready. I will start with the, so I have used the sequence diagram, but okay, I can do it manually. It's okay. Just for you to know, if I want to have the duty cycle, I have a sequence extension, standby, lowering. So I don't want to control it manually because if I do many measurements with different conception, I want to have the same things to compare. So I have automate my system by using a sequence diagram, which exists for any user of Automation Studio. You don't have to know anything about control technologies, about a ladder diagram. You can use this. Of course, for users who have knowledge about SFC, ladder diagram, electrical control, or CAN bus, external PLC control, you can use also this external control. But for the moment, I use this that sequence diagram to automate my system. And now I will start my measurement. So I will hit this command here, and I will now trigger my simulation. So you see, of course, the sequence occur. As soon as normally this condition has been declared true, as soon as we have leave this position, and we're gonna get at the end the performance. So if I have many operational mode defined here, if all of them are green, it means all the measurement of the performance will be done for each of them. Here for the presentation, I go really with a simplified way to not make the webinar too long. So you see automatically the performance has been added automatically with a specific expression, and you can recognize blue function, black variable, and value. So first remark, we have on the drawing 1, 2, 3, 4, 5 dynamic instruments, and we have only 3 performance measures. Finally, the first constraint is not a constraint, it is just a restriction for the moment. Only the dynamic measuring instrument taken on component are taken into consideration for this measurement. But don't be afraid, the measurement can be written by yourself manually. You can use any variable in the system. This is just a shortcut to help you to finally to avoid to waste a little time to edit anything like this. So this is my performance, and I will explain. So for the moment, the output flow, we can see here, this performance is explained by using an operator that is listed here. I'm gonna take a few seconds to explain the syntax, sorry. So the variable output flow of the component H31, so we talk about, sorry, I will just move a little bit this page here. So H31 is this pump, the output flow, and I would say the average output flow of this pump is between, during the duty cycle, so between the beginning and the activation and termination, is roughly about 42 liters per minute. I'm sorry, I could have selected I could have selected, I didn't change the unit, but it could have been measured in, of course, in gallon per minute. And we give the value, the average, with a percentage. This percentage is just based by default, but you can adjust this in the way you want. Now for the second, so we use automatically this value, and we use the average also. So it's done automatically by the simulator. The second value is so cycle time. This is not translated. This means cycle time of, so we talk about this component here. If we see the tooltip here, COM12-1, the cycle time during the duty cycle is between 2 seconds, blah, blah, and 37 seconds, okay? Why 2 seconds? Because I didn't start automatically my, you see, my, I mean, it has not start automatically. When I hit the simulation, I have started the sequence, I have started the motor, and after 2 seconds, the extension of the cylinder stopped. And the other important, I think, the other measurement is the energy consumption. So the energy consumption is between, so it's a very small unit by this value and this value. So almost, I don't know to pronounce, sorry, but this, the minimum value of energy consumption at the beginning was this one, and at the end we have this one. Okay, so now how we are able to use this? If I return into my presentation, I have identified my function, I have specified the operational mode, I have measured my performance. How can I use these features now to help me to improve my design and to be sure I improve my design? So when I want to improve something, I have to select my criteria, and my criteria in my case will be the energy consumption. The timing, I have to impose the timing of the sequence because the container has to be empty. So we keep the timing. So for the moment, I will just keep, so I can save all this performance, but I don't need this for the improvement of the conception. I can keep this one if need be. And I'm gonna show you how to try new concept, new design, and compare with this performance. So I will save it first. I will delete the dynamic measuring instrument I don't use. I do not have to do this if I use functional group, but as I told you, we have no time to demonstrate the usage of functional groups, so I will go quickly by using this way. So I have to manage to delete my dynamic measuring instrument. Now, I will keep those two values, and to, as an example, we have in this circuit, obviously, we can see that when we are so let me start the simulation. For example, here I will start, I want to illustrate something here. So when I am in this sequence, so here I am in, I force, if you want, I force the position here on the standby position. So I have force with my sequence diagram, I have force manually. And you can see that the oil is laminated through this valve because this valve is on the center position. There is this valve that block the position of the rocker, sorry. So obviously we can improve this during this standby position. We can add a functional group that will depress this circuit during this phase. And this is the objective of what I'm gonna show you right now. So I have put in the layer, in the layer a depressurization circuit. So I will make it visible. So I have added few components. So this is an example of a functional group. A functional group is a set of inseparable components that create a subfunction. So the subfunction here is depressurization of the circuit. So it was hidden and it was not simulated. Now I will simulate it and I will restart again my my simulation. So I will just hide this. And now I will, so now if you don't mind, I will use a graph set just for people who are who deal with this type of ladder diagram, SFC, or electrical control. I have used SFC. I don't want to focus, but just for you to know, we have this SFC that is controlling by this cut button the sequence. So it is exactly the same, but we use another things. So I will start my simulation, not my analyze, but my simulation. not from this way, but from the operational mode here. What I just want to hide this one. Okay. And now I will start my measurement by controlling the system by the graph set. So the sequence is the same. There is no, I didn't use this to have different performance. Don't be afraid. This is exactly the same sequence. We have to wait 8 seconds and so on. And eventually we can just display the, so this is the current behavior. This is a normal behavior. Just to compare, I have locked this plotter just for comparison. So, and now we're gonna get the new performance of my system. So if performance are the same, they won't be added. We will see exactly what's happened. So here we see that, or maybe I change a little bit some stuff. Okay, so we have a shorter, or so maybe I should have start with the sequence, but with the same sequence, but it does not mind. The important thing here is the energy. You can see the energy consumption in this. So this is the minimum, this is the maximum. And you see that globally, the energy consumption with the second design, this is the maximum value here, it's roughly the 50% of the first value we have measured with the first design. So it is, of course, the hydraulic is simplified, the example is simple, but it is just to show you how easy it is to be able to compare design, different solution of design using this module. So we're gonna now go into the analyze. So we have seen a little bit, if I want to recap, the usage for design. There is many things you can do more, but of course we have no time to cover everything. So now I will jump into the, I would say, how to generate an analyze and get a report based on the component failure mode on the system. So to do this, I will keep this, but and in order to, I hope you have understand a little bit how about all those tabs. This is important. I have created in my system, if we get back into this duty cycle, I have focused on this standby position. This standby position, what I want to do is to conduct an analyze only for this operational mode, and I will trigger many component failure to see how it affects this operational mode and how it affects the system itself. Because of course you can figure that when your truck is lifted, you can figure the problem if you have any problem at this position. So the objective is just to focus the analyze on this, but you can conduct the analyze on the entire cycle or on any cycle you want, of course. Sorry. So what I have done, I have, if I open my, sorry, I have to detach this here. And I just want to, what I want to show you is operational mode. So I have created the standby position. So I just want to go overview, have an overview. Standby position. The standby position will be applied to the rocker function. Of course, I want to measure the performance. I mean, to measure the performance, it has been already done, but I will use it to conduct the analyze. As you can see, you use these features when you want to measure performance or when you want to conduct analyze by this button, and we're gonna reach it soon. The activation condition. I have mentioned at the first at the duty cycle operational mode, I have used this A0. If I want to have more precision, I can use here in the tooltip, you can see on the 5th line, the rocker percentage position. This is the sensor of the cylinder I use. Instead of using a non-off signal, A0, I use a real value of the sensor position of the cylinder. So the activation condition is when I explain it in percentage, when the position of the rocker will be greater than 90%, we're gonna start. This will be the goal to measure, to evaluate the performance of the system. Not to evaluate, but to analyze the current performance and compare them with the existing we have specified here. Termination condition is 8 seconds. I told you about the 8 seconds I have imposed for my standby position. So we don't need any sensor. We just want to have this timing. So you see, all the time, this value is the chronometer, not the chronometer, but the timer, the local timer of this standby position. Okay. And the performance has been measured and modified, explained in such a way. We need to have the position of the cylinder to be between 90 and 92%. If not, we're gonna specify. So if I stretch a little bit, there is more information you can put in this system. So I don't want to go on to this option, but maybe we're gonna talk later. And as soon as I declare, I know my if I don't have this performance, I can already, as an expert of the system, if my position of the rocker is not this value, I can define the local effect completely because it is local to the component. So I can say, okay, the actuator does not maintain its position. So this is an information you don't have to put, but it is better to put it right now because you are in the process of this analyzing this standby position, for example. So if you don't have the standby position, you have a problem. And so maybe I would say it will be more accurate to say the rocker. I don't know if it is the actuator, but it is the rocker does not maintain its position. Maybe it could be the actuator. It could be another problem that creates this. Sorry for this. I have to fix this. So now I save it, and I will be able to launch my analysis. So now I just verify those. This standby position is activated, is green, because I will. If it is green, it will be used during the analysis. Duty cycle, to not pollute too much the report because it can be huge. I just want to deactivate this because we have used it to improve the design. It is done. Now I am more in the technical aspect of the system. While here I was more in the not the efficiency, but the economic, I would say, criteria of the system. So now I am gonna, if I just recap here, I have complete my performance. Now I'm gonna conduct the analysis. So I will close this window, and now I have to open the failure manager. This is the last dialogue that has been added into this module. So we have the function operational mode. This one was existing, and this is the failure manager. So three new dialogues. So this failure manager, there is two tabs. The first tab deals with the data used to conduct the analysis, while the second tab is for the report itself. By default, if I click here, it is empty because I didn't conduct any analysis at this time. Okay. By the way, as soon as I display this, IEC standard recommend this type of information. We will see this later. But other standards like MEL, maybe they have other information. Okay. And the same for NFX. So I return into my data analysis, and in this data analysis, the first things to select, so if you remember, we have declared few components, few failure mode components in the system. So for example, if I have my motor. So just if I don't know where from what I'm talking about, I can follow the link and just grab where is my okay, this is the motor. The same for the cylinder. So and anytime you can recognize that the components that are highlighted finally are the ones that have the failure mode declared in them. Okay, so this just for your information, this table, you will see you can normally, if you use BOM, the features BOM in Automation Studio, or if you use the report features, we have the same. If you know how to use this or BOM, you will know how to sort, to filter, and to use this table. It is exactly the same architecture. Okay. So what is important? We have few columns here. So we have the failure first. When we're gonna launch the analyze, we will be able to select the component, the failure mode. So this is a list of component failure modes. So if I just select my component, I will just group by component. Maybe it will be easier. So here we have the failure that are declared for the double acting cylinder, for the filter, for the counterbalance, and so on. So I have declared only few, but you know by experience that each component in a system during its life cycle has a problem. There is seals, there is spring, there is mechanical lock, there is I don't know the word, usure, I mean, okay, used component. Of course, as soon as you get older and used, you have problem for components. We can declare, I have declared few components, few failure, and to ask the simulator to take into consideration those failures. So of course I can select all. I have no time during this webinar, so I will unselect all, and I will just show you at the end. I will show you a complete report done on another system to have an overview, but just to show you how it works here. So this is to initialize the component. We have now this column will be live during the analysis, because we will have we will have visual icon. We have some description here, and important thing, you can eventually force any type of failure during all the analyze. So I recap, the analyze will be done selecting one failure, launching the sequence, evaluating the performance, compare with the performance required, and get back information there is a system failure or not. But you can force all the time manually. So you can combine failure, which is not really handled by the IEC standard. But with Automation Studio, you are able to do this. So now the parameter, I will get back later on this. We have start condition. So the start condition, as we're gonna study only the standby position, I can just grab the same condition that we have here, activation condition. I will use this one. So I will use the same start condition, and I will use for end condition the same, I will use the same I will use the same termination condition than we have on the standby position. So because it is a specific, I mean, I focus only on one aspect. But if I have all the many operational mode to test, I have to specify the beginning of the cycle and the end of the cycle. So as soon as it is done, I will validate, and now I think I am ready to start my analyze. So I will close this. I will just zoom all component, and how to start. I think let me verify. I think it's okay. I can start my simulation, my analyze. So I start from this button. Yes, I want to save. So this direction show you which failure you are testing. So automatically, oh, sorry, I didn't, I don't want to, I'm gonna automate. I don't want to hit the reset button or the sequence diagram or the manual button. So I have an easy function to force this button to be activated at the beginning of the simulation. So if I use the sequence diagram, I can also ask him to start each time by itself at the beginning of the simulation. And when I start now, let me just get back to the main circuit and I will start. So there is the dialog and the sequence will start by itself. So the timing start. So the failure, what does it mean? This failure is under test here. So we have external leaks in the cylinder. Okay. And during the process occur, I will comment a little bit the parameter. So the parameter deals with the type of analyze. So the first thing is I'm gonna first talk about the maximum analysis cycle time. We know that our cycle time in the duty cycle here is roughly 40 seconds. But for any reason, figure you have in your a failure in your pump. Okay, you have a failure in your pump, no flow. So it means the sequence won't start. So you have to specify a maximum value for a timeout, if you prefer, to say to the simulator, okay, after this time, skip this failure and go on another one. The other is just some automatic. So I will, maybe if you have some question, I will answer. Automatically, we see we have a failure here. Okay, we have a failure that has been added, and the second value is under testing. So if you have 20 component failure mode activated, you will have this cycle that will be launched 20 times. At the end of this system, of this analyze, we get a partial report on the system. So of course, as we have only one function, sorry, I don't want to group on this. All the failure, the system failure belong to the rocker. Of course, we have only one function. We have now the different data that has been implemented automatically. So for example, the detection mode, we have the simulator has measured the performance, have detected they are under the required performance, so it declares a failure. We have the local effect, that it is information that you can fill at the beginning, while some information can be dealt with by the simulator. So just to recap, where you have qualitative information or numerical information, quantitative information that are filled automatically by the simulator. While you have, I call this objective information, in the sense they can be done by the simulator. It's a measurement. There is no rule of thumbs about this. It is a measurement. But there is subjective information for which the simulator can't help you, because we don't know the concept. For example, the global effect, we don't know about the global effect. So is it a problem that can occur on people? We don't know. So this is subjective information that has to be filled by expert, like you used to do in a meeting with many people, like it is done currently, finally, with an Excel document. And some information, potential cause. So potential cause of what? Of the component failure, of course. So it could be it is in link with the cylinder. So it could be the seals. It could be the cylinder scratch, for example. So I just have to. So you have to fill this with with information by yourself or with a small team, or you can finally you have to get expert to fill those data. This is qualitative information and subjective information. In the meantime, you have quantitative information that can be shown here. And this is where you have the calculation of the risk priority number. So the criticality of the system failure mode. So the detection, this is given by the standard. So for example, the detection, if you double click, you have a list of criteria that grade the importance. So if you can detect easily, it is almost certain to detect like an external failure, for example, an external leaks. An external leaks, you can see maybe oil outside. For example, here the external leak, we can declare that the detection is maybe not almost certain. It depends if the cylinder is visible or not, but you can figure. So let's say it is high. While the internal leak is maybe not so easy because you can see. So let's start by doing, okay, let's keep it is very low to detect it. So it is important to put this value in the way, and here you have the calculation that is done. So now we have to figure who is using this report. If you are in design mode, it means maybe if you want to increase the capability to detect, maybe you can recommend action by adding a speed sensor, for example, adding or pressure sensor. This is when you use it during, so of course, when you use it in the design, you don't have to fill everything. You can, for history of the design, you can keep this report just to show what are your analyses that make you add a sensor. Okay. If you are in, if it is a report is used for technical support, maybe you have to recommendation first. So it could be a process, diagnostic process you can describe here, and you will be able to share this diagnostic with step 1, step 2, and so on. So this is the way you can use it. So I see that the time is flying, so let me open a project that will control. I have 4 minutes left, so I will just open. So the report finalization, I have been very fast. So let me open the project I want to show you, in which there is an already done report. The objective of this is I have completed my reports, how I share it with the support, technician support on the field. So what you have to understand here, it means, for example, if you are on an offshore system, you have a problem on this offshore system. What's happened in real life? People call the facility, and they will say, okay, we have this symptom, we don't know what we have to do because there is the productivity has been reduced in terms of pumping system. What can we do? And this is the symptoms that are sent to the I would say the headquarter facility, and the people who are dealing with FMECA will be able to use such a report to filter according to the symptom. Will be able to filter according to the symptom, will be able to filter this dialogue. So in this example, I have, it's not the one, I have many failure. What, I'm sorry for this. Maybe I have some filter here. All. Okay, I think I have more failure in this system. Okay, I think I have. Okay, so this has been launched with. Sorry. This is a report done on this Valor Press. We have generated, starting with 25 component failure mode. We have generated, I would say, almost 60. 60. I think there is more, but maybe I have some filter that are okay. No, it's a 60 failure. So now let's figure this is the global report. Let's figure the guy on the field told me that the productivity is reduced. So I will grab here some keywords, and I think it is the key of this, the conduction of an AMDEC, an FMECA, is to have some keywords between all the user, because if you relate the symptom with some keywords, you will be able at the headquarter facility to have some how can I say this? Okay, I have to. You will be able, you need to speak to have the same dictionary of word in order to be able to filter the data in a good way. So here, for example, do I have a productivity reduce? Let me see, productivity reduce. I want to filter if you want. Okay, what's happened here? Okay, I think I have no time. So I try to figure my filter. I don't want to lose time here. The objective is let's filter on some effect, a global effect here, for example. I will take 1 minute. So I will create a filter. I will use this one. Maybe it's productivity. Maybe okay, reduce. Okay, anyway, I have no time. I want to filter this, and at the end, I will get a report. So I have generated, in order to get this report, you will have the filter that has worked. Maybe it is done. And you will have to share this information. Sorry for this glitch here. To share this information with people, you have many things. So you have report that has been filtered. So you can generate a sub-report according to the filter you have generated. And after this, you are able to share it. So there is many ways to share a report. You can export it in different format. And you can also, so PDF, Word, Excel, but you can also generate it by using a standardization of your report. So for example, I have done a report. Let me close this one. I have created a report here where I have already filtered. And if I get the print preview just to show you how we can deal with standardization, it could be helpful for in your company if you have specific standard of sharing information with the field. So this is a way of standardize the report information. Excuse me. But to be honest, I would recommend another solution, because here I generate my report. So let's figure you have the Baller Press, you have some symptom reported, you have all the data. So this presentation is an example, of presentation, of standardization. You can customize in the way you want, of course, but now the final solution, and it will be my last word, is if you know, you have to know that we have an Automation Studio viewer. This Automation Studio viewer is able to open the project I am showing right now. The Automation Studio viewer will show only the visual data that are displayed onto the document, won't be able to see what is behind the component. And why I'm recommending this? Because when you are in the report, it is easier to follow the link towards the document rather than reading everything of information. Okay, we talk about the press actuation, we talk about the component directional valve. Okay, you will have sometime I don't know, you will avoid to waste few seconds, maybe few minutes, but as soon as you want to be efficient, any second, minute is counting into the process. So I just finalize by returning here. So this is the way sharing the information, and I recommend really for you to share it free, the Automation Studio viewer. So maybe just to recap a little bit, you have advantage to use it for design department, support department, but of course you can use all this documentation for, not documentation, but features for training and also technical publication. And for corporation, this can help to democratize this working process and to help to improve the decision process to stop a production or not, depending of the severity, criticality of the system. I think I have to close, and I will return to Bruno. Thank you for your attention.
Okay, so we do have a few questions. Dennis, I can maybe start asking them if you're ready.
Yeah, I just want to close this project event off. I don't know. We're gonna see. Okay, go ahead. No problem, Bruno.
Sure. The first question is related to the component failures. The question is, do you include standard failure modes by default in component libraries? So we're talking about specifically the troubleshooting in the component properties, which failures we have by default.
Oh, you mean in the library here, in the component library?
Yeah.
Okay, by default, we have, if you grab a component from the library, you will have a component failure. So there is two types of component. There is specific failure that are existing, but they are not declared. Because declaring a failure create a variable, and we don't want to really add variable for nothing. If you don't buy this module, or if you don't have troubleshooting, I mean, we don't want to pollute. So by default, it is not declared. Just to recap, we have specific failure and we have generic failure that can be created for any type of component, because this generic failure deals with ports of the component. We talk about failure leaks, internal leaks, external leaks, restricted port, and block port, but they are not declared by default in the library. If in your case you want, for example, in manufacturer catalog, if you want, you can create your own catalog. I don't want to show the, I mean, I can create a user library, or I don't know, I will just create quickly a library. If you create your library by yourself, normally it's better to create a catalog information, catalog, because you have more information, more data. But the objective, you can declare all the failure you want, not activate, don't activate, because it means it will start during simulation. So let's figure you have external leak. So by using on port A, on port B, and so on, as soon as you have declared them and you add them into your catalog, okay, you have seen how to create catalog, I guess, at the first webinar. And now, if I open my component, they are declared. So you can configure the component failure mode to be declared by default, but we don't offer this. I mean, we could, but we don't want to pollute. I would say it's not pollute, but if you don't have this module, it will be not very. I don't know how to say this. I hope you understand. Does it answer the question?
I think so. Yeah, I think so. I think basically the question overview was how to be able to manage, create your own failures and which ones are already available. So I think that covered that pretty well. And as you mentioned, if you store them within your own library, it allows you to be able to recuperate those already declared failures. So you don't have to go back and redeclare them.
Exactly. And just to finalize, each component has specific failure. So depending of if it is a motor, you have the, if you have jam rotor, transmission shaft. I mean, you have for cylinder specific, for electrical motor, you have other specific plus the generic. Okay.
Good. Second question is, can we analyze one failure at a time?
Yeah, of course, you can analyze one failure at a time. So if you are in, as soon as you want to analyze one failure at a time, you do. It depends. The question is, if you are in your system here, if you remember, I talk about this parameter, but not too much. If I launch, this is automatic. It means we have all the failure. First, all the failure you have declared in this tab are analyzed one at a time. Okay, but if I understand the question, as soon as if you put a semi-automatic analyze, it means as soon as you get the first detection of system failure mode, the system will pause and pop up this dialog and show you how, so maybe we can just show the thing. As soon as we go one by one, semi-automatic, it means as soon as it's gonna reach this failure, the report will pop and you will be able to enter your report. maybe it is not exactly the question. Can you confirm?
Yeah, the question is can you analyze one failure at a time, or can you analyze multiple failures at a time? I think the question really originates from how you can manage the different combinations of failures, but you're showing this right now by activating the true condition.
Yeah, okay, this is the true condition for the analyze, but you can force other failures to be on during the analyze. Okay, so this is the result of my, you see, it is only one line orange. It means as I am in semi-automatic, I can fill my report and continue after I have filled my report, the analyze. There is different way to combine failure in Automation Studio. First, you can force during the analyze. You can trigger, for example, you want normally the IEC standard recommend to test one failure at a time and only this situation. But because we are in a new digital model, in Automation Studio, I can declare, if you know this feature, I hope you know, if no, you need to know, you are able to declare, for example, you have fluid jam piston, for example. If I select jam piston, I can say, I can ask the system that this failure will be activated if during simulation I reach maximum pressure or maximum temperature and so on. So during the simulation, even if your system, you didn't declare this, you didn't, it is not during the analyze, it is not the failure that is analyzed. It does during the analyze, if the, for example, the maximum pressure is reached on the cylinder, this failure will be triggered during the analyze. So there is a combination of failure possible, which is not finally handled by the IEC standard, just to recap. Okay.
Good. We have some, I'll try to maybe put the questions together based on the topics. I guess there's some different questions that are related to the functions and functional groups. For the two tabs that are available in the functional groups and functions, what are the difference?
Okay. Okay, but to illustrate this, I will open this. So I will go on the Baller Press, because on the Baller Press we have. So let me go to the analyze report. When I have done the demonstration, I have only one function in my system, and so I have few operational mode, and I consider all my components to belong to this function. But in the Baller Press, you see, I have different functions. So the installation, the system is the Baller Press, but there is different functions. So for example, you have as soon as the baller is arrived on the press, there is the activation of the press. This is an entire sequence. I mean, there is different operational mode for this this function. After you have the stack pressing, you have the gate open, ejection. So this is different function in my entire system. But of course, as you can see in my system here, where I am, this one. Okay, here you have really, for example, you have the manifold. You have the manifold. Finally, a function, if we want to resume quickly, a function is an actuation. It's not completely 100% true, but you can simplify getting this explanation. If you have the gate cylinder is a function, the ejector cylinder is a function, and maybe they are independent. And this is where, when you generate a report, if you have a flat system with only Baller Press function, when the time is coming to filter because you have some symptom explained by the technical support, if they tell you, okay, I have a problem in I don't know, the fast approach. If you have no filter, if you have only one function, you can't filter where is the fast approach. I have no this operational mode in my system. I have no this functional group. So you will be able, you need to have many words, keywords to be able to filter your data. While if you have explained your system in different function with functional group, you will have, you can locate the failure quickly just by clicking this. So here I'm showing the point of view function operational mode, but I was talking about the operational group. Here we have just fluid system. We have different operational functional group. So for example, you can see here, this is a report. So this is the list of system failure, and the system failure are shown by functional group. So for example, in the manifold, you can figure, if I, maybe this one, there is a lot of issues. I select the manifold, so I can see the system failure mode that occurs in the manifold. In the functional groups, it means the cause is in the manifold. We have, for example, all the failure, 54 failure. If I go into the ejector cylinder, I have only 17. It's not small, but I mean, you see, by creating this functional group, you are really, you are able to filter. And this is the usage of the functional group in this system. But there is other usage in the report when you want to simulate specific, for example, if you have a machine with different option and you want to simulate the machine with no option, you can declare functional group to be as many different, as many options. For each option, you can declare a functional group, and you will be able to simulate all the options using the functional group. Maybe, I don't know if it is the objective, but if you want, I can show you quickly in my system here how to create functional group. So I have here my hydraulic installation to be, I will deal easily. So you have the installation circuit. I will hide it just to create. For each functional group, you can declare the oil and the media and so on. So I will just hide them just to facilitate the explanation. So my installation is the rocker in this example. Okay, my installation is the rocker. If I my first circuit, let's figure it is a pump group. Okay, pump group. The pump group, as I told you, a functional group is a set of inseparable components that create a sub-function. So the pump group is a sub-function of the system, and it is mandatory to activate the rocker. So we have the function, the pump group. To create the pump group, it's so easy. I mean, currently, if I use this command, all the components belong to only one functional group. If I want to be more accurate, I will select, finally, if I consider my pump group, I have only those components, including the relief valve. So what I have to do, I just have to declare, it's just a question of drag and drop, and that's it. Now I can see my my pump group. I will be able to see. So if I add the other one, oh, I have to create the other one, sorry, it was already belonging. If I create now the second functional group, sorry, I will delete, I will copy this one just to recuperate the name. So I have to copy and paste. I will just wait the autosave in progress. The functional group are really used for the analyze to sort the information, but as you can see, if you can make a BOM based on a specific functional group, for example. So you can use it in many features in Automation Studio. So I will copy my functional group, paste it. So now my second functional group will be, won't be, so it belongs to the rocker function, but it will be, for example, actuation. The group of actuation of this rocker. And I will add another one, which will be the depress circuit. So depress circuit, for example. This is a function by itself. If you remember, the system was working without this depressed circuit. So depressurization maybe. Okay. And the way to create this, once again, is just to take the component. So prior doing this, I want to recap for people who are using, and we know that some customers use to do this type of feature using the layer. So you won't lose your work by with the layer. Just for information, if I do where is my, I try to display my layer. I think it is here, sorry. Just have to grab my window. So my layer, I have made the example. So for example, if you have already, and we know that people, some customers, sorry, has already split the system with the layer, but the layer is okay, but is not enough, because first the layer is belonging to only one document, while this go through all the project, all the technologies, and you will see after to define the function that the layer can be used. But if you have used the layer for this, you can just drag the layer on the functional group. It will be automatically created. The activation, let me verify. So let's figure my activation, the one I will just hide this one. Oh, I think I have taken a lot of okay, so I think this one is the layer. Okay, let me, except this one, I just have to take this layer, and now I have my functional group. Okay, so for example, now I have my functional group already done, and if I get back to my report, I have, so of course, the function and the duty cycle, and you have also the visualization of the failure mode of the system that occur in the system. Okay, so we have this in the rocker. So maybe as I didn't configure at the beginning with this, I have to redo my selection here. So to define the rocker, for example, first design, it's only this. Know this, okay? This is the first design. And here we will see how we are locate the failure modes, system failure mode, by belonging to one other functional group. So if it is, I think we can explain for people, for customers, sorry, who are interested to use this functional group, we can go deeper in other presentation. It is not really the topic of this morning because it was an existing function. Other question, Bruno?
Yeah, we have by 3 more questions, 2 of them related to the reports, and then by a third one that I'll ask you. That'll probably be all the time that we have. So one of the question that we have is the report automatically generated, or must input manually? Okay. So yeah, sorry. So just to reiterate the question, Dennis, sorry. So is the report generated automatically, and also which parts of the report you need to fill out manually?
Okay. Okay. If we have here, we have all the report, most of the important information. You have 2 types of information. There is some objective information. So let's figure the, I don't know if I want to show you the blur press. Anyway, to illustrate my explanation, there is information that are completely objective. For example, the component failure mode, which are trigger the system failure in the rocker. This line, for example, this is an information that the simulator knows, so he is able to write it by itself. All the information like the function, the operational mode, can be done automatically by the simulator. The detection mode is based on the performance, so it can be done by the simulator. The component that is the description, the component that handle the failure mode is known. The location is known. And so this is objective information that can be done by the simulator. What can't be done by the simulator is subjective information. For example, if I return into my picture of this hydraulic circuit or maybe of the truck here, if I display sorry this, the severity of a problem that occurs if the cylinder if the two cylinder in this case leaks, for example. The simulator does not know that some people can be, I don't know, a technician can be a dog, anything can be under this mechanism and can be hurt, okay? Or maybe you can break completely the system or your truck lose money. So you have some evaluation that the simulator don't know because it don't know the context of use of the system. Okay, but the expert knows that if there is a problem in the seals, internal seals here, and for any reason it could have people, the objective information, the subjective information must be dealt by human person, not at all the computer. So I hope this is important. The same thing, for example, the report regarding the potential cause. Of course, at this time of Automation Studio, the simulator is using a cylinder, but the simulator does know the technology of the cylinder or the motor of the electrical motor, so it can't say, oh, there is a problem in the cathode of the. So it is depending of the technology of the component. So this is something that can be filled by expert. The same, the gravity, the detection, the simulator knows that the external leak is easier to detect than the internal leak. But we don't want to propose value. We have value by default, and you have to fill it because you have the experience. And so just to recap, subjective information has to be filled by the user.
Then maybe just a quick info. If we go to the report properties, just to maybe mention the columns, I think that would also be helpful for anybody who wants to be able to build their own like a template of how they want to be able to structure this. Just understand that those things can be modified.
Oh yeah. This is the default value recommended by IEC, but here, like any workshop, you have the standards of this module. So the analysis report is showing you the default standard we propose that is following the IEC, and you have a set of let's talk about the alias. It will be more understandable, I guess. So here, this list of attributes are here, local effects. So as you see, they are displayed. So by default, this is what recommend IEC, and we propose it. So you can define, for example, the item identifier is for Automation Studio. You don't want to display it into your report, so you don't show it. Now, if you want to create your own, first you are able to copy, copy the standard, duplicate, and modify it. So you can modify it by using adding a field, for example, and this field can be a properties, a normal properties, a string. It can be a calculated property. What is a calculated property? It is exactly that, like this failure risk priority number. So this is the quantification of the criticality of the system. If I select here, I can see there is a calculation that are done that take into consideration severity, occurrence, detection. If need be, you can completely modify this by using other field in the Automation Studio, field that exists by default, but you can create by yourself. Okay, so, and this is when I talk about these three standards, I think that I think those three standards offer different criteria of information. And specifically, for example, if I go into other type of property like severity, we propose the IEC law. This is the standard for severity. So this is the same thing, except I'm going here. And here you have a list of criteria. You can, so for example, I think in aeronautics, the scale is 1 to 100. I'm not sure, but I think in automobile, it's automobile, sorry, it is another scale. Maybe the term can be modified. You can minor, you can very minor 1, very minor 2. You can modify anything. You can add a different value. And as soon as you modify, you can adapt this to your technologies. So you can configure completely your standard.
I think, but just really quickly, since we're at the end time, one of the questions was, do we need a special license for the failure analysis tab? I'll just answer that yes, it's a module that we'll make available in the Automation Studio 7.0. If you're interested in obtaining a quote for that, please contact your technical sales representative. And last but not least, the question on the how to export, the final report into Excel. Yes, you can do. You can export those into Excel files, and then related, can we use scripts to create certain connections to either workflows or other Excels? You have access in Automation Studio to different APIs that you can use, but you can also use some Excel macros in order to be able to manage some of those as well, external to Automation Studio. I don't know, Dennis, if you wanted to comment on that as well. If not, then
completely. You're right. You can export the report in any format. I mean, not any, but you can see all the format. And you can of course. So normally people, customer used to. I think from what I know, Excel is used, so you can export in Excel. And but don't forget about the viewer. Sorry.
Good. Okay, well, look, I think we're at the end of the webinar. Thank you so much, everybody, for attending. It was really great having you. Thank you so much for the great questions. Please join us next webinar. We'll be going through, I believe, it's the simulation webinar, where we'll be going through some basic features, a little bit more basic features on the Automation Studio simulation, but also diving into different proof of concepts on simulation, which we invite you to attend. So as mentioned, you received the link for this webinar. Following, I'll send an email out for the link. So anybody who was not able to make it for the complete presentation will have access to the video. Thank you so much, everybody. Have a great day.
Thank you. Bye.